Welcome back, everyone. We're on day 29 of the series now, and we're going to be working on problem solving and data analysis problem types. We're going to head straight in here, and I'm going to give you guys some tips and tricks on the way that helped me score a 780. First problem. The scatter plot shows the relationship between two variables, x and y. An equation for the exponential model shown can be written as y is equal to a times b to the x, where a and b are positive constants. Which of the following is closest to the value of b? Okay, important facts in the problem here. It says a and b are both positive constants. Therefore, we know that if b, whatever a is, if b is greater than 1, our function is going to be increasing exponentially. If b is equal to 1, it's just going to be a line, and if b is less than 1, it's going to be decreasing exponentially. So we need b to be less than 1 in this situation so that we follow this predicted shape on the graph. Therefore, our only answer in which b is less than 0 is a. And it's asking which of the following is closest to the value of b. So A will be our answer for that one. It's a hard problem, but it's really based on your knowledge of just graph behavior. So you need to know how an exponential graph functions. Okay, the second problem. The positive number A is 2,241% of the sum of the positive numbers B and C, and B is 83% of C. What percent of B is A? Okay, we're going to start out with this fact right here, one at a time. So we know that A is equal to, before we even write out the equation, we know that 2,241% divided by 100 is going to be equal to 22.41. So whenever we multiply something, we want to multiply it by 22.41, not as 2,241%. Now we can write our equation. Since A is the sum of the positive numbers B and C, A is equal to 22.41 times the sum of the numbers plus B and C, as stated in the problem. But we're trying to find what percent of B is A. So we need to set A equal to only B values. So to do that, we need to look at this fact right here. Let me clear this up for you guys. It says B is 0.83% of C. So 0.83 of C, or 83%. So C is going to be equal to B over 0.83. And we can substitute this in to our equation. So we have A is equal to 22.41 times B plus B over 0.83. Now you don't want to simplify anything, you want to do this all at once. So you're going to have A is equal to 20, we're going to do it in our calculator. It's equal to, we're going to do the parentheses first. So to calculate this, just say it's 1 over 0.83, like this. And then you get the coefficient. So 1 divided by 0.83 is going to be like this long number, 1.20481, whatever. That's why you keep it in the calculator. Then you add 1 to that number, since the coefficient for B is also 1. And you're going to get 2.2048, whatever. And you multiply that same number in the calculator by 22.41, and you get exactly 49.41 B. So, looking at our answers, it's not that and it's not that. Now we're in between these two choices. 49.41, which is what we have. However, that's as a percent. And remember what we did at the beginning, where we divided by 100 to get our decimal form of the percent. So to convert back to decimals, we do 49.41 times 100 is going to give you your percent, which is 4,941%. So be careful with this trap answer over here, that it's not correct. So D is going to be your answer for this question. And yeah, we're going to look at the next one. In a sample of 80% of the Okay, in a sample, 80% of the items are faulty. There are 88 faulty items in the sample. How many total items are in the sample? Okay, so in this question, it's asking for how many total items are in the sample. We need to set up a variable. We're going to call that variable, let's just say X, for total items in the sample. So we know in a sample, 80% of items are faulty. So in the whole sample, so 0.8, that's equivalent to 80%, times the whole sample size is equal to 88 faulty items, correct? Because 80% of all items in the sample. So now it's asking for how many total items. So we isolate this variable. X is equal to 88 over 0.8. And your answer from that is going to be 0.8, 110 items in the sample. Very simple and easy problem as long as you know how to set up your different variables. This is a fill-in question. You're going to put 110 into the computer and you should get your points. Not too hard of a problem. We're going to do this final problem for today and call it a day. So we have this chart. We have values, the frequency of each value in dataset A and the frequency of each value in dataset B. Dataset A and dataset B each consist of 27 values. The table shows the frequencies of the values for each dataset. Which of the following statements best compares the means of the two datasets? So if we're comparing the means, we want to find the means of each. And to do that, we need to multiply the value by how many times it appears, its frequency. So I'm going to set up a little chart over here. And this is going to be A total and B total. So to find the total for each category, as we're going to do, we just need to multiply each. So for the first, it's going to be 30 times 2. For this, it's going to be 60. And then we have 30 times 9, which is 270. And then we have 34 times 4, which is going to be 136. And then we have 34 times 7, which is going to be 238. And then we have 38 times 5, 190. It's a very long question. Very easy, but very long. And then luckily this is the same. Then we have 42 times 7, and that's going to be 294. And then 42 times 4, 42 times 4, which is going to be 168. And then 46 times 9, which is 414. And then 46 times 2, which is going to give you 92. Now that we have all our values, we're going to add them up at the bottom down here for each question. And we're going to get 60 plus 136 plus 190 plus 294 plus 414 is going to give you a total of 1,094. And then for the second one, 270 plus 238 plus 190 plus 168 plus 92 is going to give you 958. Just checking I did that correct. And yeah, okay. So now to find the mean of each one, we want to divide by the total number of values we had, and that's given here, 27. You could also count the amount of frequencies that appear in the chart, but if it's given to you, that's a much faster way. So now this is going to be 1,094 divided by 27. It's going to be 40.518, and it keeps going on. And then this one down here is going to be 958 divided by 27. It's going to be 35.481, it continues. Okay, so we have the mean for A and the mean for B. And we can see A's mean is obviously larger. So the mean of dataset A is greater than the mean of dataset B, exactly what we were saying. We can go through each of these just to make sure the mean of dataset A is less than no. Mean of dataset A is equal to no. There's not enough information, no. Okay. So very, very easy problem. Just takes a long time. That's why it's hard difficulty, especially on a time test like the SAT. So just use your time wisely, and you should have enough time in your test to grab up free points like from this question. If the video helped, please subscribe to the channel, and I'll see you guys on day 30.